Great. So I'm going to talk about our properties library today. So this talk, I'm just going to start out with what is properties, why do we use it, talk about how it works, and then give some examples of kind of some of its features in action. So what is it? It's just a pip installable Python module. And in this module, there's a couple things defined. There are property classes defined, and then there's has properties defined. So let's talk about properties first. So these property classes, they define a type. And so what they define about that type is how is it validated, how is it serialized, and how is it documented. So like for example, you might have an integer property. So that's validated, you just make sure it's an integer. So the validation would be something like, is this an int? How is it serialized? It's probably just serialized to the value that it is, nothing complicated there. And how is it documented? Maybe it says that this is an integer. And then of course you could have much more complicated properties that have more complicated validation, serialization, and documentation. And the other thing we have is has properties classes, and these are classes that will have properties. I guess that's pretty self-explanatory. So these they have our properties that we define. And so with no extra work in the has properties class, you already have validation, serialization, and documentation just straight from the properties that it contains. And it's set up so that with a little bit of extra work, you can add event notifications and set up some defaults and add a bit more validation than what comes with the properties. And hopefully this will all be clear as we go through some examples a little later. So let's see, why did we set up this library? There are a few really useful things that come out of our properties and has properties classes. So first is consistency. Developers who are making these has properties classes can set expectations. So they can say, I want to define this class that has these certain properties that fit this really specific case. And then the users who are using that class are then guided towards those expectations, so that really the developers and the users are working with the same thing. Like the developers say what it's going to be, and the users are really easily guided to exactly what is expected. These classes also have simplicity. So the developers can build classes in a really declarative manner. So they can just say, okay, well I want this property that's an integer, and maybe give it a name and a description. And that's all there is to it. So when you're looking at the code, it looks really clean and understandable. And then that kind of bleeds over to the users. So when they're actually using the code, they encounter this clean namespace that they can kind of explore and figure out how things work just by looking at documentation and working with the code. And there are a few other advantages to using properties. It has some built-in customizable utility like automatic documentation, which kind of feeds back into simplicity for both the developers and the users. Developers don't have to worry quite as much about documenting every little facet. And then users have this documentation to use, regardless of what the developer did. There's also built-in serialization and deserialization, which makes it easy, makes these classes a bit more portable, and you can save your work and come back to it maybe. So this is pretty similar to a few alternatives like IPython traitlets and in-thought traits. Both of these things have really similar fundamentals. They're just developed in a slightly different environment. So traitlets is developed for like the Jupyter IPython environment, and traits is developed with in-thought canopy in mind. And so this is just our own take on that idea, just kind of molded exactly how we want it. There's also MyPy, which is a bit different. It enforces static typing, but it's more like when the code is compiled, it checks to make sure that things look right. And it doesn't really actually have much effect on interacting with the code. So let's talk a bit about how this works. So first we're going to define a has properties class. just really simple thing that hopefully most people kind of understand is just a book. Maybe it has two properties for now. It has a title and a number of pages. The title is a string, and pages is an integer. And so this kind of comes back to the declarative, easy to read sort of description of classes. Like if you look at this class, there isn't very much extra in it. You have exactly everything you need. You have the name of the class, it's a book. You have the name of the properties, titles, and pages, and then you have descriptions of those properties. So that kind of goes into our simplicity Y category. So then when you make this class, you are creating the property instances, and then you've defined a property class. And how are those related? Well, the properties class actually has pointers to these properties. So then we can make an instance of a book. So now we've made this actual tangible instance of a book, and we can start to explore that some. So first we can take advantage of our documentation. So it's formatted for Sphinx documentation, so it's useful with online docs and linking between different classes. When you're just looking at it in text like this, it looks a little bit funny, but you can still kind of see what it has. So you can see that you have a parameter pages, you get the description and what type of class it is, and the parameter title. And all of that is, so the only documentation that we actually wrote when we were defining our classes was just this number of pages and title of book. Everything else is just automatically generated with the class. So from that documentation, we know that the book now has a couple parameters. It has title and pages. And let's then now go and get the documentation of one of those. So those are actually properties, and you can get the doc string for that property. Cool. So each of those is kind of like a pointer to these property instances. And now we can start to work with this. So let's just go ahead and set the title and the pages. So then what happens when we actually set these properties? Hopefully it doesn't just overwrite and lose the property values here, which it in fact doesn't. So the setter uses these properties to validate the values that you passed in, so it makes sure that Fluent Python is a string and fits whatever other validation was in that property class, and it checks that the 792 was an integer, validates that, and then it stores it elsewhere on the class. So there's this backend variable that actually contains the valid versions of what you assign to those parameters. So we can take a look here if you're about to give it the number of pages of the book, and then you get scared and you accidentally type eek a lizard because there's a lizard on the front of the book, then the developer really hopes that you aren't actually giving a string for the number of pages. So this is kind of setting up the expectations. Like the developer who wrote this book class doesn't want pages to be a string, so that's their expectations. And then in fact, when you try to set it, the validation goes to the integer validator and it throws an error. So that's kind of just the basic sort of setting properties. Now we can go to this nice user exploration that I talked about. So you can just like explore the namespace. So you can see title and pages. Those are your two parameters that you can set. And then besides that, there's a few other things. There's validate, serialize, and deserialize. So let's talk about validate first. So this is another sort of validation that's in place from the developer. So this is separate from the actual property developers, or the property validators that are going through the property classes. This is actual validation on the has properties class. So it's ensuring that not only are the properties set correctly, is the whole class built as the developer expects. And so right now, the book that we defined on the previous page was, we defined all of the properties, and so it is valid. So now if we go here and we define another book, which doesn't have pages because it's a book about Zen, so we don't need pages, we just need a title. Right? Then we try to validate that, it doesn't pass, even though you passed a valid parameter in for the the one property that you assigned, you still didn't assign all the properties. So validation of the actual hasProperties class failed. And one other thing to note, this is kind of going back to user interaction. So you can construct these classes in slightly different ways. So if you just want to like create a book and then assign the property of the book as separate lines of code, you can. Or if you just want to construct it all together in one big bundle, you can construct a book and pass in the properties. Anyway, so it's just a bit flexible with user interaction. That's kind of a separate point. So let's go back to our namespace here and see these other things. So the only two things that are left are serialize and deserialize. So the way that the built-in serialize works is it just serializes your class to a dictionary. So it contains the name of the class and then the property values. And you can, so this is just a built-in, just like the documentation, the person who writes the class doesn't have to do anything for this to work in just like a simple way. And then you can make a new book by just deserializing your book dictionary, and you can see that your new book is pretty much the same as your old book. And so, I mean, you could take this dictionary and write it to a file and pass that around as a JSON object. So that's kind of the basic stuff that's in properties and has properties. But all of these things can be very much expanded on. So I'm going to now go into examples, which sort of expands on a few different of these points. So for example, in validation, you can provide additional validation to different properties. So for example, integer, you can pass in like a minimum, for example, or a maximum, and that just sets up an additional piece of validation. So not only now is it validating that it's an integer, it's also validating that it is greater than or equal to 0. And if you try to set it to a negative integer, then that fails. So that's just more validation that can be built into the property itself. You can also modify how the validation of the class works. So here we say that we added one more property to the book, which is the color of the cover. And we said it's not required. So now, when you validate the book, as long as title and pages are set, then it is valid, and the developer who wrote the code is happy with it not having the color. So here we're creating a new book, we're just setting the title and pages, and validate is true. Whereas before, when we didn't set pages, validate was false because pages was required. And again, this is kind of what I talked about before. The user can define classes sort of however they want. Another piece of validation that's a bit separate from that is that these properties can not only validate values, but they can coerce values into something that is a bit more consistent. So color is a good example of that. So the color property gets coerced to just an RGB triple of values between 0 and 255. So if you pass in, say, magenta, then the actual value that's saved to the instance's backend is 255, 0, 255. So now, if someone else was writing some code that worked with a book, they could be sure that the book color was this three integer value rather than some sort of string or something else mysterious. Something else that hasProperties allows is for handlers. So handlers are just methods that are fired on set or on validate that can just provide more validation. So this is more of the person who writes the class setting up the behavior that they want. So for example, this is a validator on pages. So in addition to having the properties validating pages as an integer that's greater than or equal to 0, we can also validate that when pages is set, let's say it's an even, it has to be an even number of pages because we're super smart here and we know that all pieces of paper have two sides. So number of pages has to be even, right? That makes sense. So then on set, when you set pages, then that just fails. So it's just an additional piece of validation that isn't really tied to the fact that it's an integer. It's more specific to the book class. So then this shows a few other types. So this validator, that's what I just showed. So this is a validator on set. You can also have an observer that responds. So this is when you set pages, it checks the value that you set it as. When you observe pages, it changes the value, and then whatever method you define here executes after the change. And you can also define just a class validator that is called when you explicitly say book.validate. So this is only called when you call validate. It isn't called on property setting or anything. A few other useful things. The developer of the class can define some defaults. So for example, if you just want the default title to be untitled, that's the new thing I added there. Then immediately when someone creates a new book, the title just starts out as untitled. And similarly, if you create a subclass of these, you can redefine the defaults. So this default is actually living on the property itself, whereas this default is living on the class. So now when you create a new little black book, then the default color is black. Serialization, there's a little bit more to talk about there than the JSON dictionary that I talked about before. So has properties classes also support pickling, which is just sort of a way to wrap up a class in Python and just unwrap it, and you can just rebuild classes using the pickle module. So you can pickle up your book, and then you can load your pickled book, and it creates a new instance of a book. You can also have some fun maybe with serialization by defining your own serializers. So this is just a really goofy example, but it actually has some practical uses. So right now we've defined a serializer that takes a value and just prints meow that many times. And now we make a new cat book, and so the number of pages, instead of just getting serialized to JSON, which is kind of the default, we've registered our own new serializers. And so then these serializers, so you create your cat book, The Rise of the Persian Empire, and it's just 10 pages long because cats are not that patient. And then when you serialize it, you can see the pages meow, 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 meow. So I mean, it's just like super, super goofy there, but there are a lot more realistic examples, like you can serialize files to binary, or even thinking about going between properties and traitlets, since they're so similar, it'd be pretty reasonable to write a serializer that can serialize a properties class to a traitlets class, move back and forth there. So you can kind of do whatever you see fit, or if you just want something that says meow a lot, then you can have that too. And then there are just a couple more slides getting into a few more advanced property types. So here we've quickly defined 3 classes. So we now have a person, which has name, age, biography, possibly. The only required thing is a name. Then we have our book, which still has our titles and pages, but now it also has an author and an editor, and those are instance properties. So those are actually instances of another has properties class. And then we've also defined a library, which has a branch, and whether or not it's public. And here we're using a list property. So then all the books that the library has is actually a list of has properties books. And I mean, just to reiterate, I think this is really nice. Because like for the developer, this wasn't too hard to write. They just thought about exactly what they wanted. They said, okay, I want a person has name, age, biography, duh. And so then they just like made that into the book and the library. It's all really straightforward, and all they had to write was just the things that they thought about. Like the name is a string, the name of the person. They don't have to worry about any of the logic when they're actually defining their class. And then the user comes in and they look at this, and I think that it's really understandable what all of this is. Like it can basically just be like read as a sentence. You come in and say, okay, a person has a name, it's a string, it's the name of a person. Okay, and age, integer, age of person. So I don't know, I think that's really nice. Then we can use these quick, so we can make a person, we can make a book, we can make a library and add the one book to the library. And then we have a valid library which actually validates everything, so the valid library has a valid book with a valid author. And yeah, so then all I have here is just kind of a list of the basic property types that we have now. So I guess I talked about integer and string, but we also have float and boolean and complex, and then some more specific types like color I went through, but there's also datetime or a unique ID, which is only generated once. I talk about instance and list advanced types. There's also union, where you can say that some property can actually be two types of property. And then we've also started to develop some plugins. So we have a PNG property that's in a separate module, but that can be imported, and it's just a different type of property. So it can be used the same way as all these other properties, even though it's in a separate module. And that's it. It's on GitHub and IPI and read the docs.